So what is it that we're going to talk about today? Record types is a concept that's relatively new in C# and the .NET platform, and what's interesting also on the Java platform is what was added recently. So I will also look on both platforms a bit. So who am I? Who's going to talk to you for the next half or 3/4 of an hour? My name is Henning Schwentner, as you heard, and I'm a polyglot programmer. That means I do programming in C# on the .NET platform, but also on other platforms. And many of the things that I'm going to talk about today are not specific to the .NET platform, but are true in general programming. I'm a proud father of 3 boys and 3 girls, and I work as a coder, coach, and consultant at WPS. You heard that. So coder, coach, consultant, that means when I'm lucky, I get my hands on the keyboard. But most of the time, I'm doing what I'm doing with you. At this moment, I'm standing or sitting in front of people telling them how to do it right with programming, with software architecture in general. And software architecture, coaching, consulting. Coaching means in exercises, in theory, I teach people how to build great architecture. Consulting, that means I work with teams on their piece of software. Sorry, work with teams on their piece of software to bring better architecture to that. And this means typically that I work on a big old monolithic brownfield software system that has to be modernized, that has to be modularized. And this software modernization, that is what I do in most of my time. And this is so interesting for me that I just published a book about that. It's called Domain-Driven Transformation. This is the German edition, but the English edition is on its way currently also. The idea is to use concepts of DDD, of domain-driven design, to modernize software. And we will see that can help us today as well. So here you can see this book, Domain-Driven Transformation. And my other book is Domain Storytelling. And storytelling, I would like to start with a little story here. And that story is about a bank. So we need an example domain so we can see how we can build software for that, how we can program for that. And this bank, well, there's a teller working at that bank, and that teller is managing accounts and the accounts of the customers of the bank. And a customer keeps his account with a bank, and a customer, for example, wants to do transactions. That means he says, well, dear bank, take money from my account and transfer it to another account, to another customer of the bank. So that's banking, private banking, also business banking. And I think we can all well imagine that there's a computer system here that supports this banking business, managing the accounts and transactions. That means transfer money from one account to the other. And to get a bit deeper into what the bank is doing, let's look at the process here. Well, it starts with our customer, and the customer, they as a first step, they open an account at the bank, an account with an IBAN, that's the bank account number. And then the second step is the customer deposits an amount of money onto the account. And then after a time, the bank pays interest into the account of the customer. So this amount here, we get interest for that. And well, then there's a last step here. The customer withdraws an amount from the account. So this is a coarse-grained, broad idea of what's happening, what's the process in the bank, or what's one of the processes here in the bank. Of course, we could go into much more detail, but for the time being, this should be our idea. Hey, this kind of diagram that you see here, it's called a so-called domain story. coming from domain storytelling, the idea is we let our domain experts, our users, tell their story. And while they are telling their story, we record what they are talking in a visual way in a diagram. So here, the domain story is a diagram, so we can show our domain experts, this is what I have understood. Did I get you right, dear domain expert? If you are interested in such kind of modeling, then buy my book, Domain Storytelling, which goes deeper into the topic. So now we have an understanding about what's happening in the domain, and we have found some domain language, domain terms here that can help us. Words like a bank account, the money amount, activities like to deposit and to withdraw money, to pay interest, and then we have an IBAN. So all these words, they come from the banking side, come from the domain. They are not about computers. So with a computer, with a software system that we are building, we want to support this part here. So how do we build software for that? How do we build software for this concrete domain here? So the idea is now, well, we want to build a software banking 3000 here. And well, to build this software, there's a sad truth for us programmers that I have to tell you here, and that is, well, we are building software not for ourselves. Software is not an end in itself. We are software building for somebody else. So software does not fall out of the sky. Software is built for a purpose, and that purpose is to make the life of our users better, to make the life of our users easier, faster, more efficient. So important to understand as a programmer is that software is built for tech people. No, software is not built for tech people. Software is built by tech people, and it is built for business people. And that means we, the tech people, have to understand them, the business people here. Because only what we can understand of the business, of the work that is done, ends up in software here. So that means we want to build software not somewhere in outer space, but we want to build software deeply rooted, deeply connected to our domain. And the domain, that is the area of the real world that we are building software for. So in our case, the domain is banking. And how do we do that? How do we build the software deeply rooted into the domain? How do we build the software so that it can grow out of the domain? Well, we do that by building the software as a reflection of the real world. So this is the real world, the work in the real world, a woman here working with an air pressure hammer. And this is the software, the reflection. And here we can see the woman and the air pressure hammer again. That's what we want to do in software programming as well. So that means programming is model building. When we are programming, we build a model for the real world, the so-called domain model. And around this domain model, we build the rest of the software. All the technical stuff, the UI, the database, all that is built around this domain model. We use all the stuff to support the domain in the end. How do we build a domain model? Well, there are several rules of thumb that can help us. And the basic idea is, well, we take the objects from the real world and we turn them into objects in software. That's basically why it's called object-oriented programming, what we're doing. So what are the objects in the real world in our banking example? Well, the bank account, we see that here and here and here again. That's an object. So that's something that we would turn into an object in software as well. And then the second rule of thumb is the actions from the real world turn into operations in software. And operations, well, that's maybe a bit abstract term. Let's say actions from the real world turn into methods in software. Objects become objects, actions become methods. What are actions? In our example here, to open an account, to deposit an amount of money, to withdraw, to pay an interest, all these are actions. And what you can see here, these are all verbs. Actions, activities are typically verbs. Objects are typically nouns. So these basic rules of thumb, we take the things, make objects out of them, we take the actions, we make methods out of them. That is the basic idea of object orientation. The basic idea of object-oriented programming. And where does object-oriented programming come from? OOP was invented by two Norwegian computer scientists, Ole Johan Dahl and Chris Newgaard. And the first language that was object-oriented is Simula. They both built it. And after Simula, the next real object-oriented language was Smalltalk. And Smalltalk brought this OO idea to the extreme, because Alan Kay and the other guys that built Smalltalk, they said, well, we have this philosophy of everything is an object. So when we build our software, we have objects everywhere. And after that, all the languages that came had to answer this question. What is an object? So Simula and Smalltalk started with, but C++ and then Java and Python and PHP and finally C# and TypeScript, they all had to answer this question. How far do we go with object orientation? So in Java, James Gosling said everything is an object, and in C#, Anders Heilsberg said everything is an object. But when we look back to our domain story here, we said, well, the account, that is an object, but these other domain concepts, these other domain terms that we find here, the IBAN, the bank account number, or the amount of money, or the interest, are they objects? Are they objects in the sense of things? Is that something that we can take into our hand and touch? Well, not really. So in the real world, not everything is an object, right? So in the real world, we have other concepts as well, and especially we have the concept of the value here. And when we look at domain modeling, at building a domain model, designing a domain model, implementing a domain model, then domain-driven design comes into place. Here, first described in this so-called blue book by Eric Evans. And he builds up a language of different patterns that can help us build a domain model. And so he says, well, we have at least two basic concepts that are important here. The entity, that's the thing, and the value object, those are the values. And the entities, they are typically things. The value objects, those are the properties of the things. And we want to model them differently. So in DDD, there are other patterns as well, service, aggregator, repository, factory. They are not important for us today, but this difference between entity and value, that's important to us because they are apples and pears. They are two different kinds of fruit, two different kinds of animals. And when we look closely, we see that already in the programming language design. So I said, James Gosling, when he was designing Java, said everything is an object. Yeah, that's right. But everything is an object except the primitive types. In short, long, byte, char, float, double, and Boolean. And the same, or maybe not the same, but something similar is true for C# and the .NET platform in general. Anders Heilsberg said everything is an object except structs. Structs, they are value types, right? So we have reference types and value types, and structs, they are not objects in the sense of they are things. So we get a third rule of thumb here, and that is we want to take the values from the real world and turn them into values in software as well. And that's why we want to have values as first-class citizens in the programming language, not only objects and methods. We also want to have values. So we want to take the IBAN and the amount and the interest and turn them into types, but not into object types, but into value types. Okay. To understand that, we have to look onto objects/entities more closely. We have to see what is an object, really. So an object is typically a thing. So we are modeling something from the real world, something that we can touch, that we can do something with. And more philosophically or more technically looked into that, we say an object has an identity. And an object exists in time. That means it has a life cycle. Life cycle means there's a point in time when the object is created, and then you can do something with the object. The object can change its state, and then eventually the object will be destroyed, and then the garbage collection comes and cleans up. So an object has an identity, has a life cycle, and has a state, and that state can be mutable. And what on the other side is a value? Well, a value is also a concept from the domain, like the entity, like the things, but it's a more abstract concept. It doesn't have an identity, it's identityless. It's an abstraction of concepts that we have here, and values exist kind of out of time. They are eternal in a way, and they do not change their state. That means they are always immutable. Entities, objects can be mutable, can be immutable. Values are always immutable. So a value does not have an identity and is always immutable. So we see the main difference between objects and values is objects have an identity, values do not have an identity. Okay. How is this implemented in C#? And interesting thing is it's the same way implemented like in Java. So in C#, objects are created by defining classes by the programmer and then instantiating these classes. So what we have in C# is so-called class-based object orientation, as opposed to, for example, JavaScript, where we have prototype-based object orientation. So what is a class? A class is the form that we use to cut out the cookies, to instantiate the objects. Or at least if we think about software as cookie dough. Then we have the class here, that's our form, and we have the objects there, those are our instances. And the objects, they have an identity. So this is a different object than this. Even if they are equal, they are not identical. And they can change their state, so we can color this cookie here, and we can color that cookie here, and the other cookies are not changed by that. Also, we can change the state like this here, and eventually this object here is destroyed, is created. And the identity of these objects are based on the reference in .NET and the platform. So this is the object, and this is a variable where we are referencing that object, and this here, the reference, the address of the object in the memory, that's our identity. So if we have two variables here that point to different objects, even if these objects are equal, they are not equal. Okay, sorry, my son has to get his gloves. Snow is outside. Okay, so we built the identity made of based on the memory address. So these variables, they are not equal because they point on different objects. Even if these objects are equal, they are not identical. This is different. Here we point to the same object, and thus we say, well, these both reference the same object and then they are identical. This is how we build the identity here. Okay. That is how objects work. And how do values work? Just a second. That is how objects work. And how do values work? Well, we have in both languages, both in Java and C# or in both platforms, we have the built-in value types. So in Java, these are called primitive types. In C# they are called simple types. And those are types like int and double or boolean / bool or character. Those are these built-in value types. Okay, and how about user-defined value types? Those are value types that we need in our domain, like the IBAN and the money amount, you remember? Okay, so we have user-defined value types, we have string, and we have date time. They behave like values, like those are our values. And those are object types that behave like value types. In Java, we call them value-based classes, or in C#, those are classes with value equality. And sorry, now I have to jump over values in Java because we want to look at values in C#. And in C# we have int and double and bool and char, and they are the simple types, and they are built as structs. And we can use structs also to build our user-defined value types. But structs are a bit strange because they are called value types, but they don't have to be immutable. So if we want to use structs to really build value types, we have to make sure that we're only using read-only fields and that we do not build state-changing methods. And to ensure that, starting from .NET or from C# 7.2, we can use the read-only struct and say, well, these structs are immutable with read-only. And well, then we get something that's quite okay. So the equals methods then will work as expected when we compare two values. On the other hand, well, the equals operator will not work as expected. Starting with C# version 9, we have record types. And now we finally come to the record types and see how they can help us build better domain models. So what are record types? Record types, they have value equality. That means record types always override the equals operator, and as well as the equals method. So both work as expected. And that is great. Also, when we override equals, then we have to override hash code. This also works out of the box. But beware, record types, well, they are also kind of strange. Then they can also be mutable. And of course, you remember for domain values, for value objects, we want to have types that are immutable. Also, when we look onto the implementation, records are on the heap. That means they are reference types. So we always have to go through a reference to get to the real thing, which might not be great for the small things that values typically are. So then we have a small value and 64 bits for the pointer for the reference to get to that real thing here. Starting with C# 10, we got the record struct. So we get rid of this on the heap. Record struct combines both. Structs are value types in the sense of they live on the stack, not on the heap. And records means we have this value equality. So we are getting close to what we really want for the domain values for value objects. But again, a record struct can be mutable. But we can combine this idea of read-only structs and record structs and build the read-only record struct, three keywords here, and then we get what we really want for domain values. And that's great. So with current C#, we can build in a very simple way, we can build value objects with just saying read-only record structs. So why do I think this is a good idea? And don't take my word for it. The whole DDD community thinks that's a good idea. So why aren't int and string enough? Why do we want different types here? Let's look at a concrete example from our banking domain. You recall that we found the amount there, right? The money amount. And the money amount, well, you remember also that the money amount is not an an entity, not an object in the sense of it has an identity, an amount. Well, it's a value object. So yeah, in traditional C#, we could use a class here and say, well, this is my class amount, and let's say this is a value object. And you see, I'm using a type attribute here coming out of n molecules. Maybe you want to look that up. It's a small architectural library to put into your code the patterns that you're using here. And how is the money amount working? Well, it's made of an int, the actual amount, and then another field, the currency. And currency is another type. And values, well, they should be immutable. So we're using the read-only keyword here. And when we make fields read-only, then they have to be initialized in the constructor. So we need a constructor here, amount. And then we want this equality. We want to say, well, there's no identity, and that means we override the equals method in a way that this amount is compared to that amount, and this currency is compared to that currency. So we are doing a field-wise comparison. Or in modern C#, we can write this in a more functional way with this syntax here. But here I go back. This is basically the same. It's just a bit more functional. And of course, if we override equals, or when we override equals, we always have to override get hash code as well. And then we might want to override the equals operator as well. So this value amount behaves like we want it to do. And when we override equals, then it's a good idea to also override not equals. Okay. And it's a good idea to override that because, well, if you don't override it, performance will not be granted. And yeah, talking about performance, these are things that are built on the heap. Classes are reference types. So we have this thing, well, here's the actual value, and here that's the pointer to the value, the reference to the value. So what we really want to do in many cases is this here, no reference, have the value directly in the memory, and there structs come into play. So we can do something similar with structs here, read only and a constructor, and we don't have to override equals. Here works out of the box, but the operators have to be overridden. That's this part here that I showed you earlier. Equals works out of the box, equals does not work. And now with modern C#, the records come into play. So we can do something like this here, public record amount and amount currency. And we automatically get read-only, we automatically get equals and get hash code and to string and the operators. They do not have to be overloaded and work as expected. So this is a much more concise way, a much shorter way to express what we actually want to do. And here we focus on what's important, how our type is called and what the fields are, and the rest works out of the box. That's great, but records still are on the heap. That's where the record structs come into play, which are no reference types. But again, now amount and currency can be changed. So read-only record struct, that is what we want to do here. And as you can see, this is only one line. And I hope that this helps many, many projects to get away from what is called primitive obsession. Primitive obsession is that we do not have real types coming from the domain, but only are using ints and strings. Here we bring many more domain types in the software, and that's what we want to do here. Primitive obsession, that's a term coined by Martin Fowler in his famous book, Refactoring. So this is a way against primitive obsession, introducing value objects. Yeah, and that's what I want to tell you. Think about your project. How can you replace primitive types with more domain-driven types? Use records, use read-only record structs. That will be the right thing to do in many places. Okay. And with that, I want to come to the end. If you want to look at a concrete example where I implemented a domain to see how this feels working with record types and generally working with a domain-driven model, with a domain model, then have a look at the Leasing Ninja, leasingninja.io. That's my teaching project where I show how software building is done right, or how I think software building, building great architecture is a good idea. Okay, and with that, I come to the conclusion, and that is values and objects, they are different kinds of animals. In modern C#, we have not only classes and structs, but we also have records and we have record structs, and they can help us a lot to make building right domain models in an easier way. Okay. What now? If you are interested in building domain models the right way, but don't know how to do it, then I invite you into my training, Domain-Driven Design Concrete. There we look in 3 days deeper into how can we build domain-driven software, how can we express the domain knowledge in our software. Also, how can we transform our old monolithic software into more modern, more modular software. Yeah. wps.de/ddd, there you can find more info on that. And while I'm doing advertising, I like to advertise for myself, but I also advertise, also like to advertise for something good. So please consider making a blood donation. After the pandemic, the blood banks are dried out in many places. So please give your arm and give half a liter of blood. And with that, I say thank you for your time. Happy end. And now I'm going to look into the chat and see if there are questions.